Okay, so with our e to the x, right, I introduced chain rule and I showed you how it works. How would chain rule work here? Let's have a go at this. Where did my thing go? Chain rule. Okay. All right, let's have a think about this. You could introduce your U substitution and that kind of thing, and you could prove the result, but I think you guys are pretty good by now. Let's see if we can do this on the board without the U and all that kind of thing. You have to differentiate the inside and the outside, right? What's the inside function? 2x. So its derivative is 2. There's my inside derivative. I multiply by the outside derivative, right? The outside derivative is 1 over whatever you've gotten there, okay, which is 2x. 1 over 2x. Inside, outside. I'll write that down for you. Hold on a second. 2 over 2x. What's going on? What's happened? What's gone wrong? Has anything gone wrong? Who thinks something's gone wrong? Who thinks we've differentiated incorrectly? So, who thinks you've differentiated? What? Yeah? No? Yeah? Who did? Yeah? Not sure what's going on? Let me ask this question instead. Log e to the 2x, right? How does it look different to log e to the x? Remember those questions? If I put log e to the x here, okay. A value like, say, if this is natural log, right? When y equals 0, what's x equal to? E, correct. Because e to the, wait, hold on a second. No, sorry, there we go. That's better, all right? Because it's the exponential one flipped sideways, right? 1, okay. Now, if I compare that to, say, log of 2x, okay, and I say, where's the intercept for log of 2x? Okay, this is log, where's e, okay, so 2x is equal to e to the power of 0, which is 1, so you're like, oh, it's a different spot, okay, so you're like, it's a half there, and you can plot a few more points, and what you'll get is this kind of shape, okay, and that's at a half. What's going on? What does this mean? If I put, where's my ruler? Here we go. Let's see how well I drew it. If I were to put a vertical line across here, right, and compare, what is the gradient at any given point along this graph? Okay, I think what you would find is the gradient is actually between these two graphs. It's always the same. What's the difference? One's been moved. One's been pushed upwards. It has actually moved left or right. You know why I know it hasn't moved left or right? Where's the asymptote? There's an asymptote here, right? The asymptote is at x equals 0. Okay? The asymptote is at x equals 0 for this function. But it's also at x equals 0 for this function. So I haven't moved left or right at all. I've just moved up and down. Okay? So this is like looking at, you know, if you looked at x squared and you differentiate it, you get a derivative. Okay? Then if you looked at x squared plus 1, or x squared plus 2, or x squared plus 50 million, okay? You differentiate them, what happens to the constant? It vanishes because they all have the same derivative. They're all 2x. Okay? In exactly the same way, because these graphs are sitting on top of each other, and I could add in log of 3x and log of 4x and log of 5x, they all have the same derivative. Okay? That's weird. Alright? Let's try another one.
No.
Oh, come on. I didn't draw it that carefully. It's not that. It's not. Let's try the derivative of, I'm going to start writing log base e. Okay? So I'm just going to write natural log. Of, say, x squared. X squared. Now things start to get a bit different. Chain rule. Differentiate the inside Differentiate the outside. What's the inside? When I differentiate it,
2x.
I'll get 2x, right? I differentiate the outside, it's 1 over whatever you've got there, right? So 1 over x squared, okay? So now I've got 2 over x. Now hold on. If you remember your log laws, you should have anticipated that, right? Because, think about this guy, right? Remember your log laws. That 2, that power, is really just the coefficient, is it not? You bring the 2 from up there, bring it out the front. So of course when you differentiate this, it should be 2 times whatever that was, which is 2 times 1 over x. Okay? My brain is melting. Alright, now, that's the basic idea, okay? But as you can see, because I'm adding all these different kinds of functions, they can combine in lots more different ways, okay? So it's a bit like, you know, you got more elements, you can make more different actual substances and materials from them because you can have more combinations, okay?